But first off, at one of our first conferences, we heard from a panel about the target number for distraction. We heard it up here a little bit, somewhere around 2 seconds or so. And, what, about 180 feet you've traveled by being distracted for that 2 seconds. What more, we kind of touched on it a little bit, kind of right across the board, but how are we really trying to keep that to a minimum? Or are we looking into the future as when we take our eyes off the road to adjust the radio, the car sort of takes over? And anybody, feel free for anybody to answer that.
I'll start with the old model was a single glance, long duration
Yep.
glance off the road, and there's a lot of research actually coming out of Sweden at this point. Trent Victor's work that said it's really the inopportune glance. It's taking your eyes off the road at the wrong time. It comes to we need to support the driver to do what they want in the vehicle. They're going to do it, and we need to use the technologies that John talked about, that Jeff talked about, to really improve how we get the driver to focus forward and keep their attention forward as much as possible. They're going to pull it away. They're either going to do it with what's in the car or they're going to do it with what they bring into the car. So let's push them forward. Let's keep their eyes forward, leave them in a position to react, and use the automation and the state sensing technology to support that.
No, I agree. I think that we can leverage the technology to put the things that are distracting them more in the field of view, whether it's in the cluster on the head-up display, or also be able to bring better integrated features into the vehicle rather than having people rely on their smartphones, which we all know they're doing today. And because it's illegal, they're down in their laps, so they're looking down instead of something that might be more in the field of view. And as you said, as we can have the cameras, the sensors, and those other systems that are able to be processed in real time to provide those kinds of alerts or to do the automated braking, if they do have that inopportune glance or there is something that jumps out in front of them, the computer can respond much faster than the human can.
Yeah, I don't know if the car is going to get to a point where I suppose we could, or we could tell you that you're not doing a good job, or go ahead and ask someone to take your keys. But the other way around, I mean, the technologies we're working on absolutely have potential to help people who can't currently drive. Paul was talking about that at the beginning. Extend the period of time that people's maybe beyond the reflexes and things like that. Absolutely, the things we talked about today can be helpful in that direction. But again, that's also not a promise that we can make in the near term. But if you just look at the level of automation that's already starting to occur, it's easy to imagine that these computerized systems are going to be able to help people drive.
But I think the car is going to learn, right? And there's already systems today. The car kind of learns your behaviors, learns what you do every day, where you work, where you live, and systems that are able to sort of track those patterns. And then if there's an accident somewhere, it'll actually, you could get a text saying you want to take another route or leave early, those kinds of things. I think we'll see more sensors in the car. Again, the driver state monitoring. So in real time, we're able to tell, is that person paying attention or not? There's no reason why it couldn't track that behavior over time. So we recognize, the car recognizes that this person, and because the camera knows who's driving, what their behaviors are over time and potentially enhance their driving or make recommendations or something like that.
I can give you perhaps one very practical, real-world, right-now kind of solution that's happening out there to try to deal with the subject of reaction time, for example, right? So as you age, your cognitive abilities and your reaction time tends to slow down, right? And so that's one of the challenges. So it's one of the challenges that we're trying to deal with. If you think about the typical, what we call forward collision avoidance or alert kind of system, there are multiple progressive stages to these kind of systems. The first one is to give the driver a warning. Hey, pay attention. There's a potential, your closing velocity to the object in front of you is potentially beyond or coming to a boundary condition where you can't brake fast enough or you need to brake, right? The next thing we do before we do anything autonomously, for example, is typically we'll dry the brake, we'll apply light pressure with the brakes to dry the brake rotors. We'll pre-fill the brake cylinders. We do a number of things to get ready for the crash such that we can be more effective in scrubbing energy and or avoiding the accident altogether by the time you do press the brakes. So then the driver's still in the loop, but the driver can press the brakes, but then his stopping time is then shorter, so you can reduce energy, right? And then if the driver does nothing, then we can apply the brakes autonomously. So there's already things like that happening to try to deal with reaction times and different ways of engaging the driver and dealing with the fact that you don't have the same kind of reaction time.
And to kind of just play off that a little bit, nearly 200,000 people a day fall asleep behind the wheel for a split second, sometimes for longer. Do you see the same technology coming into play with that as well?
I'm going to chime in both, skipping back to the last question and the same forward one, is not only do I see the vehicle sensing and detecting age impairment, I see the vehicle potentially being a platform for everything from health state detection to mobility impairments, probably before the doctor can pick that up. We change pattern in reaction time, we change pattern in mobility over our lives. The power of big data and our ability to mine that big data and the differences in our patterning in trip taking is all things we can harness. So that information can not only tell us when not to drive, and the question is how to move that conversation from a technology and data-centric to a personal conversation. That's the big challenge. To a health detection platform where we can see that the driving task is potentially, as a colleague of mine, Bruce, has pointed out multiple times, maybe the best stress test anybody engages in a daily basis. So we can potentially pick up pre-disease. So when you think about aspects of lane departure, how do you feed that back into a connected feedback system to the individual and give them a cue? We know it's okay right now, but you need to work on correcting this looking forward. So maybe the ticket today is not the incentive because, it's only cash. Maybe it's the threat of the fine in the future that we need to look at. So the sensor comes down, you departed the lane, you get a warning. No big deal. But the next fine is $1,000, not a big incentive kick. I got to think about that more.
Anything else? We talked about data an awful lot. All the data that our cars gather. Who owns the data? Anybody?
Nobody knows.
That was a room full of quiet.
I think there's a lot of different types of data that's going back and forth. I'll speak to some of the basic connected cars, and there's services, and there's searches that you do, and so it's usually who's in the cloud that's at the other end of that. Is it Google that you're doing a search? We work with Audi and Google to actually build a whole connected car system. Every time you do that connected search, just like you do on your browser, Google knows what you've searched for. But then there's also other systems, whether they're OnStar or others, that there's privacy policies and all that, is the OEM who manages that. But it's pretty uncharted territory. As new services, new features come out, just remain to be seen.
Yeah, I would say that's not the right question. I mean, I think the right question is, what's the purpose of the data, right? And if you start from the customer's perspective, which is, I think, sort of in my time in the auto industry, I've always, all my mentors always said, start from the customer and work back. So if you start from the customer and you work back, the data we're talking about is designed to first and foremost, protect the safety of the driver and the occupants, and make sure that that car is a safe and secure environment. So safety and security of the customers. So that's really the question about data. The question about data is what is, not who owns the data, what's the purpose of the data? And I would say, certainly from our members' perspective, and I might even venture to generalize a little bit across the industry, it's always about the customer first and the customer's safety and the security of the customer in the vehicle. You have to start from that point. That's the question. The question isn't who owns the data. The question is, what are we using the data for? And we're using the data for the safety and security of the driver and the occupants.
Thank you. And my final question is, and sort of plays off of Paul Paravano and his, God bless him, because his 16-year-old daughter just got her license. But typically, and probably the technology we've already talked about, but typically novice drivers within the first 6 months of having a license get in a crash. Do you ever see the ability of the technology being able to sort of preset that car for a novice driver to be able to do, I mean, Ford has it a little bit with their MyKey system where you can, set radio volumes and speed and all of that, but maybe do some things that will really cause some extra alerts to the car to really be able to help that novice driver.
I'll start. I mean, a huge amount of this, it's software now. So we have the hardware in the car, it's a different app, or it's different settings in an app. Just like you might have some kind of, child mode on your TV that blocks out certain things, or whatever it is. You have the ability to regulate. The car potentially could again, with a camera detect who the occupant, who the driver is, and there would be presets that you could have in place to regulate speed, regulate hours of operation, any number of parameters. And these things can very easily be programmed. So I definitely see that there's that. Again, like you said, if you're straying out of the lanes or doing certain things or regulating the speed, you can have the car adjust. And it just comes down to software programming.
So you could geo-fence the car to stay within a certain area?
Sure. Anything's possible.
Paul, start working on
That's
that.
the beauty of having a software adaptable platform. I mean, that's really the beauty of it, right? It creates some challenges, right? We're moving more and more away from a mechanically oriented world into very much a electronics and software driven world. But as long as you have the computing power and the right controls, then we have, I'm not going to say infinite, but darn near infinite capability to do these kind of things.
The one thing that from the inside the industry and working with automakers that we see as the big challenge is that the mindset for so long within car companies is, okay, we have a challenge, we're going to build this car, we got to control the cost, right? And from a technology perspective, it generally is minimizing the technology that goes in the car, because if you put more in, it costs more money. And I think what we've seen in the computing industry is that nobody goes out and buys kind of the cheapest, lowest power laptop or whatever computing device you can buy. You basically say, I'm going to have this thing for a while. I'm going to invest a little bit more. I don't know what apps I'm going to need to run next year, but I want to make sure they're going to run. So you kind of up the bar a little bit on your system. What we're seeing now with the software-defined business is there's going to be new apps that you want to run in your car. And if you have a system in there that won't support it, you're out of luck. And so I think from the build for the future mode, I think we're going to see car makers think a little bit more about that and the updatability of the car.
Great, thank you. Let's open it up to questions. Let's start right.
This one's a little bit wonky. So in terms of how this innovation is getting funded, right, is it more, we've got all sectors represented here. We've got advocates in the audience who are trying to influence safety. We've got a university on the podium. We've got the private industry on the podium. We've got innovators and advocates. In terms of developing this stuff, who's the bigger driver? Is there government money going into this based on advocates, or is it the auto industry saying this is where the big bucks are, I'm going to do it? Or is it idealists like the Age Lab saying we're going to do this and somehow it will get funded?
I mean, just in the discussion of five of us here, we touched on lots of areas of development and research that's taken place, and so I would say, the collective answer is all of the above. I mean, we're participating in consortia with other OEMs to develop standards. Some talk John did about the connected vehicle safety, V2V, V2X. We've been working on that for years in a consortium of 8 or 9 different OEMs. Some of it's government money because the safety potential that was talked about, right? So there's interest from the regulator standpoint that, wow, if this technology could really pay off, just think about the safety benefits. We'd love to bring it to the market because it's got these benefits, but we can't. That's an example of a technology. We can't just decide on our own to bring it to market because the two-way radio I might put on my car may not talk to his car, to your car. So it's a collaborative technology, that one in particular. By definition, it's got an established frequency band that it's going to talk on. And if someone else takes that band, then we have an issue. So some things have to be done collaboratively. And there's lots of collaboration going on. Universities working together. I talked about some of the human factors studies we do with participants at universities. Mentioned Carnegie Mellon, and we do work at a lot of universities around the world, and sometimes it's with government money, other private money.
I think there's a real.
All these areas are important to us.
I think there's a real shift in funding, and especially in the U.S. It's a lot different in Europe. In the U.S. in particular, we used to live in a research world that was highly government funded. And the reality is, from a government funding perspective in the U.S., the money's not there. So increasingly, academia is funded by corporate clients who are looking to the future and willing to invest in that future for competitive advantage. In some cases, it's collaborative with other manufacturers. In some cases, government is involved. But we're looking at this point in time to an industry-sponsored leadership in R&D as opposed to what traditionally was 20, 30 years ago as a government-funded leadership. Now, a lot different. Look to Autoliv in Sweden. Sweden, our Volvo's R&D budget is about this big. Well, the government supports that because, quite frankly, transportation safety is important there. Here, we fund a variety of different things. But even if you look to pharma and life sciences, where's the money coming from? Industry.
How do you see this technology serving to prevent people driving when they're drunk? And I don't just mean people who may have been arrested or under some kind of provision, but people who may have had too much to drink at a dinner party or something like that. And how can we might make them inoperable?
So I didn't cover it. I tried to stay fairly compact in the discussion, but we've also amongst the leaders in developing alcohol sensing, non-invasive alcohol sensing in the car. It's unlikely to come into passenger vehicles anytime in the really near future, but we can see it very practically coming into heavy vehicles, so the over-the-road segments and some of these fleet services and these kind of things where, whether it's school buses, there are areas, there are pockets where we can imagine this kind of thing start to be regulated more easily and to be implemented more easily as a sort of an aftermarket or an add-on after a vehicle's already in service. So there's quite a bit happening there from an alcohol detection standpoint. A lot of work going on at the research level at Autoliv and other companies there. But again, an autonomous emergency braking system doesn't care what state you are, doesn't care male, female, doesn't care whether you're young or old, doesn't care if you're a good driver or a bad driver, or what the weather is, quite frankly. It's going to stop when it senses that danger is imminent, right? And so that's the kind of the beauty of it, actually, right? It's not judgmental in that way.
I think, if I understand your question correctly, is that obviously there's never going to be a way to prevent people from getting into a vehicle, whether it's an autonomous vehicle or not, when they're drunk. I think it will come down to policy legislation that in the foreseeable future, the driver still is in the loop. The driver's still responsible in all these situations. So even if the car is going to stop itself, that driver, if they're drunk, they could get written up for being drunk. I think when we get to the point that it crosses the threshold where you have, if it's the Google car scenario, where the car does drive itself, it's probably going to be okay to get in that car, past the legal limit if you had to drive the car. But I think we'll just see what the legislation ultimately comes out to say.
When you're talking about, the car, like the Google car, where you're not driving, so it's responsible if you get in drunk, it's okay to get in drunk. At what point, though, not okay to drive drunk, but at what point, though, when the car makes a decision that maybe the driver wouldn't agree with, is the car responsible, or is the person responsible who takes the legal hit, and how do they determine that?
It's the Google engineers that go to jail. No.
I mean, that question is a part of every one of these discussions. I don't think any of us said that we're attorneys on here. I'm certainly not. But I think we all kind of talked about this transition and the progression of technologies from where we're at today to providing all this great assistance and support and help. And then someday out in the future, you call it the Google car, but it's not ready to be driven by people in normal driving situations with your family in it today. But someday in the future, we all envision that a car would be able to take over for all these situations, and then the driver doesn't really have to do anything. Well, at that point in time, the responsibility has probably changed. It's like getting on a bus, or getting on a train, or getting on an elevator, right? You're responsible for pushing the button what floor you want to go on, and then whatever happens after that, you didn't have too much involvement, did you? But we're really a long ways away from having that level of automation from a practical standpoint.
I'll actually say it's a lot closer than you think, and it's very close. The law of probabilities says that Google or somebody else driving an automated vehicle is going to have an accident that leads to fatality eventually. Law of probabilities. It is 100% certain that at some point in time someone will walk in front of an autonomous vehicle. And the moment that happens, it will set off the chain of custody of figuring out who was responsible. Now, right now, we all have is it the engineer? Is it the software developer? Is it the company? Is it the person who should have hit the stop button? There's a lot of ifs. But as soon as that happens, we will set off a chain of events that we as a society who is unwilling to accept drones, automated vehicles, harming people will set off that chain of events. We will also set off the chain of events from a policy regulatory perspective. Sorry to jump on John. That will fundamentally curtail what the three people right next to me here are capable of doing. So, GM wants to invent Super Cruise, which is probably a good technology, well embedded for us. If Google hits somebody out there tomorrow, or better yet, somebody walks in front of the Google car, because the probabilities are probably equal, guarantee you GM has a regulatory problem to deal with, because you know what? It's automation, and we're all going to look at it. It doesn't matter what level of automation. We can't buy a vehicle today without automation. It's called ESC. We need to begin to face some of these problems. We need to do it before we have the situation of who is responsible. Because it's an ugly, ugly legality problem.
The only thing I'd add is that just as the technology evolves and develops over time, the regulatory environment and the legal environment will evolve and develop over time. The real question is, in what ways do the technology and the policies develop? Do they develop this way, separately, two divergent paths or unrelated to one another, or do they develop in some sort of synchronized way? But I think that, the only thing I would add to Brian is that it would be, you shouldn't expect that the policy environment stays static while the technological environment evolves. The policy environment will certainly evolve along with it.
So I have a question.
I'll add one thing. If there are any lawyers in the room that need to direct their focus, this is an area of law that's going to get really interesting. There's a lot of money to be made.
Right, but it's fixable. These are policy questions. These are fixable. I mean, these are not reasons to have a negative view of the development of the technology. These are, in any other kind of technology development, you're going to have policy questions and decisions to make, and these are doable.
And I think the real question is how do you kickstart the policy and the decision-making questions so we can educate people, especially at the policy level, now, before there's a public outcry and a public reaction? I mean, the real key is how do you soften and set direction in a level-headed, calm environment, which we have today, before it is a reactionary environment. And I think it's disastrous for safety when we get to that reactionary environment. Because I think we're in a good place right now if we can move forward with it sooner than later.
And I'd say some of that's happening. I mean, the NHTSA, for example, is doing research. Some of us are participating in it to help figure out. On one hand, you could argue with these technologies, boy, do they offer so much safety promise that from a policy standpoint, we ought to be encouraging them to go faster to get the safety benefits? Or are the risks of electronic gremlins such that we should slow everybody down? Don't know. So there's work going on to try to figure out what is it about these technologies that regulators might want to be concerned about, and so some of that's happening. And I know, members of Congress have also been very interested in these technologies. There was a hearing in Washington in November that a couple companies, including ours, testified at. The interest is building, and I think that they're starting to figure out, what is it that they need to worry about. But on the other hand, you don't want to start worrying about things that don't need to be worried about too quickly either. So it's an interesting area.
So I think one thing to keep in perspective is that we are mostly here all talking about global companies, right? So we think about policy as a domestic issue because it's closest to us. But in fact, the automakers and companies like Autoliv and NVIDIA and others, we are global companies. We need to consider the global environment. And policies differ, whether it's spectrum or regulations or the view on who's responsible for what actions happen, whether it's the individual or the company or whatever. It's different globally. And even though that my company takes a safety perspective on just about everything that we do, we can't ignore the fact that the amount of time spent in a car is probably the single most profound opportunity to unlock productivity in this world, right? I mean, there are very few opportunities to unleash so much potential productivity of the time that we waste, if you will, in a car. Right? So if another country or another area or region or whatever decides to put in more favorable regulations, decides to put in money perhaps or policy or whatever it is to encourage us, and they can unlock this productivity before we can in the United States, then we also have a challenge on our hands. So there's more aspects to consider than my myopic focus on safety. Right? There's some other driving issues here, and we've got to think about what's happening in a global context as well.
Great, more time to work.
Yeah, sorry.
So I guess along with autonomous driving and people being a factor in accidents, maintenance is also a big part of the car. And a lot of people, like, they're driving around with summer tires in the winter, or, their brake pads are shot, and if you're accidentally, if the computer's taken over and breaking the car and there's no brake pad left, that's a big part of it. So isn't there any sort of, as maintenance cycles get longer, 10,000 miles, 15,000 miles now, are you guys thinking about systems that are being built in the car that kind of help with that? Because it doesn't seem to be brought up a lot. People not maintaining their car. AAA. How many times do you respond to people that, something could have been easily fixed, they avoided it. Now they're stuck on the side of the road, or they cause an accident because something failed.
15,000 times a day.
Yeah.
In this area.
To me, again, it's software. It's an application. It's the systems in the car all talking to each other, data coming in, and what we end up doing is we work with automakers to develop this computing platform. But at the end of the day, it's GM or it's Audi or it's Ford who says, what is that application? What's the interface, and what's the data that's collected, and what do I do with that data? Much like you have an application for your PC. This is an application in the car. And I think what you bring up is great. And there's starting to be some of that monitoring for the customer and dealer relationship and service being a part of that. But sure, the car can monitor all these systems and send that data up to the cloud, and you get an email or a text saying your car needs new brakes, or your car's, check the tires or whatever. So I think it's an opportunity for the car makers, their dealer network, to have a better relationship with their customers.
It can almost be as bad as a drunk driver if your car is not safe.
Sure, sure.
No, yeah, it's a good point Danny made. These reminders, emails, things that's already happening with systems. I mean, if you happen to have OnStar in your vehicle, you get emails right now that says, check your tire pressure, time to change your oil, and we're doing a lot of research, and we're looking at launching some enhanced capability to that around other systems on the vehicle to be able to tell you about the maintenance state, to keep it safe, to give you a heads up if things may be wearing out, things like that. So there'll be a lot happening there too, and that'll work hand in hand with these other systems we're talking about. It's all software.
If you
need to get people to pay attention because we still go out and get an awful lot of people who run out of gas, and there's a big gauge there.
Well, if you drive a diesel now, if you drive any one of the diesels now with AdBlue, sorry, this is me. I have the microphone, so I'm going to hog it. But if you drive a diesel now with an AdBlue system, you can't turn the car on. You get to a certain level with that stuff, and it won't allow you to restart the car. Do you think there's an opportunity there where if, your brake pads are worn to within 10%, you can't drive away?
I mean, all these things are options. You got to make customer choices that work, right? But those things are all feasible.
Right. I think you just need to text them while they're driving, and then they'll pay attention to it.
Hang on 1 second, George. I'll get to you in a minute.
I want to highlight something that for me was very profound. On one of your slides, under autonomous vehicles, there was the phrase, driver as co-pilot. That was a flash of inspiration for me. And I want to come back to it and ask you, can we use that sort of concept of autonomous vehicle in a much more constructive way? Right now it's bimodal. You've got normal cars, you've got Google cars with no steering wheel or brakes. No. None of you have talked about all these options in that way. You haven't said it's either or. You've all implied, and this one phrase stated, driving effectively and safely is a shared task. Now what's happening now is what the driver is responsible for and does, and what the technology and the systems embedded in the vehicle do is changing. We don't know where the end point is. It's not going to be 100% technology. I'm very doubtful about that. So I think that driver as co-pilot is a way for us to diffuse a lot of these difficult, even antagonistic discussions that we get pulled into. Will it happen? Won't it happen? Well, the answer is yes, but we don't really know how much and how fast. I'd like you to comment on that, because I think if we pick that up as a simple definition for the broader public, and this is a media event, of what autonomous driving in real world terms means, that might be a very positive step forward. And I'd like to get a reaction to that, please.
I'll just set it up because I think it was my slide. But the technologists to my left, the smart people will give you the answer. But just to respond to your question, that was precisely why we chose the language. In the policy and communications world, you don't choose your language by accident, right? You don't just sort of guess. And I think what we were trying to convey were a couple of things, and they've been conveyed, frankly, more eloquently already. But one is the notion that the move toward autonomous driving is a continuum, right? You've heard that, and John talked very beautifully about it. The notion that you're seeing the technology. I drove a car on I-95 between Washington, D.C. and New York City on a Friday night, 3 Friday nights ago. Well, any of you have been on I-95 anywhere in the Northeast on a Friday at rush hour understand the hand-to-hand combat notion of the experience from time to time. And this car had the technologies that you heard described. The manufacturer of the vehicle, when he lent it to me to experience this particular drive, described this as the most autonomous vehicle we have. Interesting, right? I couldn't let go of the wheel. I mean, I could take one hand off and I had no feet on the brakes for hours, or on the pedals rather. But the notion is it a continuum? So that was the first thing we were trying to convey. And the second thing we were trying to convey is the point you said very eloquently, which is that it's hard for us, at least in our limited minds, as sort of people at the intersection between technology and policy, to posit a future where you're totally absent. So what we were trying to figure out is some phrasing that connoted the notion, that described the notion that you're in the game. It's in some way, manner, shape, or form, right? That you're not totally out of it. And Brian used the pilotless plane analogy, and he and I had that conversation this morning. And I was one of the guys who said, "Never will I get in a plane without a pilot. I want to know that there's a system manager in there, somebody looking at the technology and at least managing it, if not flying the plane." So that's what we were trying to get at. So I'm pleased that you picked up on it, and I'll leave it to the smart people to pick up from there.
John, it's a real good question. It's why I look at the concept of driver focus. How do we promote and use the technology to support driver focus? But I'm going to call upon who I consider one of the grandfathers of the field of human factors here, Tom Sheridan. And Tom's work through his career at MIT, looking in human supervisory control and collaborative decision making. It's a collaboration between the technology and the human. It's a system. Tom most likely had a lot of the elements back many years ago. In aviation, for a while in the 90s, they tried to engineer the pilot out because the pilot was the source of the errors. So we got to get them out of the way. And in the last 5 or more years, it's become, how do we support the pilot there? Because the pilot, elegantly in many accents, as I mentioned earlier, the Miracle on the Hudson and many others, is there when the systems fail. It's a collaborative system. We're working with developing the art of system science. How do we integrate the human as an important decision-making role, who does make mistakes occasionally, with technologies that can cohesively support them?
I think that the point of it being that continuum is exactly right. And I look at, again, what we're seeing with the announcements with, Google, we'll set aside for now, but if you look at the car companies that are bringing technologies to markets, have rollout plans for these technologies. And I'll cite our friends at Audi, who have basically demonstrated cars that are driving themselves in certain situations. So you're on a highway. The system knows you're on a highway. You cannot engage this feature on regular roads. You can only engage it on a highway. The system is programmed in a certain way because it knows there's not pedestrians out there. Everyone's going the same direction. It also knows which roads have lanes that work. And also, there's ways that they can track weather. And so they won't enable it to work under certain weather conditions. So once you engage this system, you do have some level of autonomy, certainly. Again, the braking, automatically accelerating, steering. But in certain situations, it's going to turn control back over to you. And so the driver has to remain in the loop. And again, getting back to the legislation, you talked about the states that are allowing autonomy. There are parts of that basically say there still has to be somebody in the car. I mean, the Google cars that are driving, and again, I see them almost every day, there's still somebody behind the wheel of that car. That's the self-driving law today.
There's one more aspect to deal with this here too. You know, John mentioned also, and it's a thing that we deal with very much on an everyday basis. Is, you know, in our passive safety world, we have certain very predictable, repeatable set of tests that we can say good or no good to a given product, whether it's one in the market or being developed. In the active safety world and the idea of automated driving at any level, we're dealing with an infinitely complex world. Right? It is always changing, and the roads don't look the same here in Boston as they do in Santa Clara or in Detroit, and nor do they look the same as they do in Shanghai or in Tokyo or in wherever, right? The infrastructure is different, the cars are different, the driving patterns are different, the human behaviors are different, and this infinitely complex world creates a certain challenge for us. And so it further supports the notion or the idea that it is a continuum, and there is no such thing at this moment as the idea that the car will completely take over, because we don't have a way at this moment to deal with this infinitely complex world. So we have to bound it step by step and increase the boundaries that we're able to deal with over time.
What I think,
Continuum's a good word. Partnership might be better.
one of the things that I think, yeah.
Well, the continuum is the progression of the technology,
Right.
but your description of, you know, Copilot partnership, whatever, it's right on. Today, when you drive, you know, you might say we don't have any automation in your car, but you do. You have power steering. You don't have to crank to start the car anymore. Most of us don't use manual transmissions, although people in Europe still like them for some reason. You're getting the benefits from these things, but you learn very quickly what its capabilities are. Sometimes you might drive with 2 fingers on the highway if it's a nice, easy drive out in the countryside, and sometimes you're white-knuckling it when it's more tense situations, right? You just automatically adapt, and that's the collaboration or the cooperation with the vehicle that you're talking about.
One other kind of continuum I think we're going to start to see, and it'll be interesting, is how these cars are really reviewed or how they're even marketed and sold. Because, you know, as we start to see these similar kinds of features in cars, certain brands are going to implement it better than others. And so much like you have your 0 to 60 time or your horsepower, whatever, there's going to be sort of quality ratings or effectiveness ratings of your start and stop technology or your collision avoidance systems and things like that.
Some of it started with the IHS report that was mentioned
Exactly.
today. And it's just one way of assessing, but
We have a question up in the back, George?
Sorry. Yeah, with regards to the OTA updates and the ability for that to proliferate throughout the industry, what safeguards are there going to be for hackers? And I know it sort of sounds like a boogeyman concept right now, but you know, aside from a 60-minute special, it's a very real possibility, not just on an individual level, but on a systemic level. Like you look at the Target hack recently, it can happen in some centralized place that can affect very many products. Thank you.
It's definitely a concern. It's a potential reality, and so there's a lot of work going in to create systems that are secure. That, you know, encryption is being used. We have systems where we basically separate something like the infotainment system from any kind of vehicle control systems and the instrument cluster. And, you know, without going into a lot of detail, basically, you know, you've created these firewalls, just like you might have in a corporation, to prevent stuff from coming in. I mean, there's a whole other area, and we haven't talked about driver distraction, bringing mobile devices in. You have CarPlay for iOS devices, Android in the car, and so there is that connectivity, right? And you think about now you're introducing anyone to sort of download software and play it. The safeguards in that case that are being put in place is you're not actually running that software in the vehicle. You're playing the graphics from your smart device, and it's displaying in the vehicle, and you're controlling your phone remotely. So there's a lot of techniques being used, but it's definitely a concern, and it's definitely something our company and really the whole technology chain up through the automakers are really focused on.
it's a requirement, just like reliability of these systems. You know, as we talk about more advanced automation, in some cases we'll have to have redundant systems so that if one system fails in a certain mode, there's another system that can make up for it, and making sure that whatever communication is happening is secure. We talked a little bit about vehicle-to-vehicle communication. So once all vehicles have these two-way radios on there, it has to be a requirement that there's a security system to make sure I can't send bogus messages to your vehicle. And that's actually one of the things that NHTSA will be wrestling with when they figure out how to move forward with rulemaking, is we have to have a secure way to do these systems.
I promised we'd get out of here by 4 o'clock. Jim McPherson, you have the last word.
It takes what, maybe 12 to 15 years to turn over the fleet, and one of the issues I've not heard addressed is how do these vehicles coexist? What happens when you get a large number of vehicles with vehicle-to-vehicle communication, or the ability to take on certain features of driving autonomously mixed in with those that don't?
I think one thing that we're going to have to wrestle with in the U.S. is there will always be a Model T on the road. In China, there's been a movement to ban classic cars from the road for environmental reasons, and the reality is all the technological developments we create are going to have to work with the Model T. Because the reality is there is a classic car buff out there, and I know there's a few of them in the room here, that will remain drivers of classics. So if we could automate the world and get rid of everything that was produced prior to today, we can probably transform safety much faster than we will be able to. The problem is integration of legacy. You talked about cybersecurity. Well, the new stuff's got to communicate with the old stuff. Some of it's going to update online in real time. Some of it's going to take weeks and years to change through the dealer fleet. There's a lot of issues there. But we need to look at the system and say for a minute, it's got to work with the new, and it's got to work with the real old continuously. I mean, look how long it took to change from analog to digital TVs. That was your set-top box.
But it's feasible. I mean, the transition from leaded gasoline to unleaded gasoline, and but it's another reason why this isn't just going to throw a light switch and we replow all the roads and start all over, right? It's not going to happen.
I mean, people ask me when we're talking about these kinds of technologies in the car, whether it's connected cars, every car will be connected. Right now we're putting supercomputers in high-end cars. Every car will have a supercomputer in it. Simple, just a question of how long.
Great stuff. Brian Reamer, Danny Shapiro, John Kapp, Jeff Rule, John Bozzella, thank you all very much. I know I learned an awful lot. I'm sure everyone here did too. I would like to just impose on you one more time, if we could just get the panel out around the corner. We just want to do a photo.
We're actually going to do it outside.
Oh, we're going to do whatever he says, outside on the deck. Thank you all very much. And thank you all for coming. Couldn't do it without you. Thank you.